take a few minutes and look at some IPv6 information. In this one, we go to the objectives here. We're going to try to cover all of the objectives, the IPv6 objectives, in this one PowerPoint set. It's identify appropriate IP addressing scheme to satisfy addressing requirements in a LAN WAN environment. Once we have an address, and we'll look at what my ISP has given me. I have a network prefix, 64-bit network prefix, which leaves 64 bits for host addresses. So that should be quite adequate for my little network of 8 devices, including phones and tablets and all. But you could have a substantially larger network. Configure and verify IP stateless address auto configuration. I'll do an example. I'll do a demo after we do as a separate entity after we do the PowerPoints here. Compare and contrast the IP address types, and this is the thing that I've seen become really significant in the testing world, that you know what the address types are and how they work, and how IPv6 actually works. It's a little different than IPv4. We look at these, and I looked at the objectives. We look at IPv4 configuration, DHCP, and the objectives of 4.0, 4.x objectives. So we will get there. But right now, IPv6, when we look at the number of addresses that are available, in IPv4, the 32-bit digital binary address, we have 4.29 billion of them available. And we have expended the issue. It's not saying that we have actually assigned all of them to devices, but there are no more available for assignment. And IPv6 has been the next great protocol that's coming for years and years and years. And it's finally here. My ISP actually does that. I get, and I'm going to show you what I get with an IPv6 assignment in order to use on my private network. And we talked about private IP addresses in IPv4. There are no private IP addresses in IPv6. Hence, there is no NAT or PAT in IPv6. So all the addresses that we get are what we would consider, or not what we would consider, what are going to be routable addresses. And in IPv6, 340 undecillion, and you can see the size of that number down here in the 340 on down the line. So we have a substantial number of addresses available in IPv6. Okay, so this is what I would call a really big number. Are we going to round out of them? Not in my lifetime, maybe not in your lifetime, but that's a lot of them. When we did this, that's an awful lot too. But when we created, the creators of IPv4 came up with its addressing scheme, I'm sure they expected it to last forever also. So address types are a big deal in here. We have unassigned and the 0::0. Remember, IPv6 is going to be a hexadecimal number. It's going to be 128 bits written in hexadecimal format, which beats having to write it in binary. The loopback address for IPv6 is ::1, where in IPv4 we have 127.0.0.1 for our loopback. We have ::1 is going to be the loopback address, the troubleshooting address for IPv6. Unique local, which are local to the locale, are going to start with FC00, equivalent to IPv4 private addresses, we're going to have a number of addresses here. We're also going to have which is, actually I skipped it, didn't I? Link local address, FE80. The link local address would be all of those devices that are connected to a switch or a series of switches. Basically, all those that can be connected together at layer 2. So it is a link address. Link local starts with FE80, and the // here are the subnet masks. This is called CIDR notation. We talked about CIDR, classless internet domain routing. What the /64 means is there are 64 bits in the subnet mask. So the /64 is the mask length, and the mask length tells us how much is network and how much is not. And you notice down here, unique local FC00, 7 bits are going to be the network. The multicast start with FF0, 8 bits. Global unicast 2000 : and it's going to have a /3, which means the first 3 bits in the default are going to be network address. Mine in my ISP, they give me a /64 address. And I guess we might as well just go ahead and take a look, or try to. Let me see if it's still up and running. Take a look at what they actually did me. I have Spectrum, as you can see. I have a delegated prefix, and the delegated prefix is the network address, and prefix of the term means network now. Network, it's going to be prefix. So mine is 2605 : A000 : 1407 : 843E, and then : if I do a : we're going to talk about shortcuts in a minute, but : means everything else is zeros, which also means that in /64, which means that I can now assign IP addresses. LAN address, we have an FE80 address, which was our link local address, and I have a WAN address that is my public IP address, or the one on the ISP side of the router, and it's 2605 A00. But you notice it's different. We go here from to BF, from 1407 to BF. So this is going to be my internal, and this is going to be my external address in this thing. And I've got obtain DNS automatically. We can actually configure our own DNS servers should we choose to do that. But a little look at what at least I'm getting from my ISP for IPv6. The addressing scheme, and this is one that probably want to be familiar with, has 128 bits, 16 bytes, denoted as 8 hexadecimal blocks separated by colon. So AB10 : CDEF : and on down the line. If I didn't have anything else after that, I could do : and we'll talk about these abbreviations here in just a second, but a : can be used one time to represent a string of zeros. So if I had 000 0 0 0 : 0000 : 0000 : A 012, whatever I could use to represent, instead of writing all these zeros, I could write a : I can only do that one time. If we do it more than once, then the system can't calculate how many zeros have actually been substituted for the : But if we had 000A, I can write that something in front of it. I can write that as A. We do not have to write the leading zeros, and we can substitute a string of zeros for with a : substitute a : for a string of zeros one time. If I had another string of zeros after that, pretend I keep going here, then I could write it as a 0, because I wouldn't have to write the leading zeros. So back to the PowerPoint, the bullets here, the byte to the extreme left is a high order byte, and the extreme right is the lowest order. IPv6s are abbreviated for convenience. The rules for abbreviating are: remove the leading zeros from the first 3 positions on the left, like we did here. The first 3, we can't, if we had a 0, 0, A, 0, we'd have to write that as A0 because we are moving or are eliminating, substituting, dropping the leading zeros. Replace 2 or more groups that contain all zeros with a colon, one time. Only one colon is allowed in an IP address, and when they start asking for legal addresses, you'll price at least one of the options. I'm most likely, there's no betting on it, but most likely going to have a colon twice. So the rules for abbreviating addresses. Addressing scheme here, where X is 00, FF is hex, FFF, it is a hexadecimal. This is let's look at some of these abbreviations here. 2001, 0db8, here we drop the leading 0, 000, 000, and in this case it can be written as zeros. We could also, and we'll go down here a little bit farther, we could also write this as a colon, 8,000, and then another set of zeros that we abbreviate as a 0. But you notice that the 8,000, we still have to write the zeros because they're not leading, they're trailing zeros. So in this case, and it's a 2001 DB8 0 colon 0 8 8,000 colon. This is colon here. We can again only use a colon one time when we write these things. I have another quick example of this. 2001 0db8 3c 00150, and then a bunch of zeros here, and then colon 12af 12ab can abbreviate it as 2001 colon db8, where we drop the leading 0, colon 3c4d, that one stays the same. We drop the leading 0 again, and in this case I have a couple of sequence of consecutive zeros, and I have a colon and then the rest of the address. Another one here, we are going to drop the leading 0, db8 8 or 3c4d colon 0015, we drop the leading zeros, and here we drop the leading zeros. We have to keep one of them again because we can only use the colon one time. 3EE and then colon. We can end the address with a colon. So how do we get these things? In IPv4, when we get there, we're going to have to configure a process called DHCP, Dynamic Host Configuration Protocol, or we'll have to statically assign the addresses. I'm going to go back to my Spectrum here, which logged me out. My internet connectivity, I hope. Internet connectivity, IPv6. I have been assigned, and I have enabled IPv6 on my router here, and 2605A00140784.3E is my prefix. That is the private IP addressing that Spectrum has given to me, which is going to be a routable address that I can use for IPv6. So this says that host 1 sends an RS, a router solicitation message, FF02::2, which is going to be to a multicast address, multicast FF00, but so FF02 is going to be to a multicast address, ICMP type 133. The router then sends a message back, a router announcement message back that tells me what the network prefix is. Once I get the network prefix, my device will configure its own IP address. Quick look here that, and this I just did this, it's DHCP v6. I have an advertisement, a solicitation, a router solicitation, and a router advertisement. And it is sending to me an IP address, or actually it's sending to me the prefix that should be used for the network. And I'll find it here, maybe a router advertisement. Anyhow, it's sending me the router advertisement, and in this case it's probably sending me more than I want, but I still didn't find it. Yeah, here we go, 2605A001407-843. But then we get an entire IPv6 address. It's trying to be a DHCP server when I really want it to only be a tell me what the prefix is. Microsoft broke IPv6 in Windows 10, so I can't do it. I have a virtual machine here. Let me drag this over. A Windows Server machine that actually will work. If I go into it and do my IP config, I have a 2605A0001407843E, and then :0. The device itself creates its own extension to the network address. So they kind of make up their own addresses when we do this. A host receives the router announcements include the prefix, allowing it to auto-configure its interface. So that's why we call it auto-configuration. Stateful auto-configuration, the equivalent of using a DHCP and IPv4. Stateful means that we're having something to help us create it. It requires a DHCP v6 service. We can have a DHCP v6 service to provide them, but then we can also have a stateless auto configuration of IPv6, and allows the client device to self-configure its IP address and the routing based upon the router advertisements. The router advertisements tell us what the prefix is, and then the system creates its own. The stateless, the steps the host performs to generate it, obtains the IPv6 prefix by communicating with the router through the router solicitation and router announcement messages, builds an IPv6 address using the prefix and then choosing the host ID value. And then it's going to check to be sure that nobody else is using that same IPv6 address by using the DAD, the duplicate address detection. And slack up here is stateless address auto configuration. The abbreviations drive me crazy. I don't know about you, but the address types are things that are going to be important to us. Unicast is still a unicast. It's a one-to-one routable IP address. Address unicasts are delivered to a single interface for load balancing. Multiple interfaces across several devices can use the same address, but we'll call that an anycast address. An anycast is a new thing. We'll go down here, jump down here to the anycast, are referred to as a one-to-nearest address. What the system does with the anycast is determines which of these multiple devices that have the same IP address is the closest, and then it will send the stuff there. It's kind of like Google search, and if you go to google.com and do a search, they don't have a centrally located device, but you get the results from the nearest Google. Global unicast addresses 2000:3, and if you remember, mine started with 2605, which certainly falls within the 2000 parameter here. /3 is going to be 3 bits. The first 3 bits, 3 binary bits of the 128 are going to be a network that are assigned with it. And then the ISPs, in my case, mine was a /64. They assigned me a character string, a string of numbers, hexadecimal numbers, /64. That becomes my prefix, my IPv6 network address. These are your typical publicly routable addresses, and they're the same as the IPv4 global addresses. Start with 2000. Shows the unicast address breakdown. ISPs can provide you with a minimum of a 48-bit network ID, and in turn provide you 16 bits to create your own 64-bit router interface addresses. The last 64 bits are unique host ID, and then we have the link local addresses, FE80, and they're going to have those. And interestingly, the default gateway and in routers, the next hop address are going to be the link local addresses, not the public addresses or the global unicast addresses. These are like the PIPA addresses of the Microsoft to automatically provide addresses in IPv4, not meant to be routed. IPv6 will start with an FE80. Unique local, FC00, designed to replace the site local addresses, basically do almost exactly what the IPv4 private addresses do, and allow communications throughout the site while being routable to multiple local networks here. And then the multicast start with FF00. IPv4, so it does the same thing. It is a multicast, goes to the devices that have a subscription to it. IPv6 addressing, and this is just kind of a global how the numbers are available. We have the global unicast, we have the global scope inside it, the organizational or the site scope, and then inside there the link local scope. Link local again would be basically things that are connected at layer 2. EUI64 address is a Cisco thing, and this is for the host address. What we do is we take the MAC address, and in the middle of the MAC address we insert FF, and then it's going to be FE. It's going to end. We're going to end here at FF, and then the next set of numbers is going to be FE. If you see the FFFE in the middle of an address, it's an EUI64. So in order to create it, the 64-bit interface, the MAC address, we split it in half and add an FFFE in the middle, and then we have a unique address. It is based on the MAC address, so it should wind up being unique, but it is Cisco, so probably something you want to know. Cisco likes for us to know the Cisco unique things. Manual versus dynamic, global unicast, we can manually assign addresses. The Cisco manual plus an EUI64, an IPv6 unnumbered, or just a manual address. So we can do manual or we can do dynamic, and we talked about stateless. The Stateful was a DHCP v6. We had a DHCP IPv6 DHCP server running. The other one was the stateless auto configuration, and we can use stateless along with DHCP. But stateless, again, router sends us the prefix the network address, and then we configure the host address. The device configures the host address. What to look for: IPv6 and the IPv4 equivalent, unspecified : /128, which is all zeros, which is the IPv4 equivalent of 0.0.0.0, which is any IP. The loopback address 127.0.0.1 : 1. Link local 169 is the IPv4 address. Link local equivalent is FE80, and this is if you don't have a DHCP server. Everything is going to have a link local, so all of the hosts are going to have this thing. Site local, that deprecated it. This was one that we had, but we now have a unique, unique local, which is the FC00, and then the global. All other Unicast are public IPs. The unique local allows communication in the local network. Anycast, same as a Unicast, none, and it is going to get the closest. It's kind of it's a very different concept. We have multiple, which we would never do before, devices with the same IP, and we go to the closest one, and the closest based on the speed to get there. Multicast addresses start with FF00, and they're the equivalent of the IPv4 224.0.0.0 multicast addresses that we have in IPv4. So that is an overview of IPv6. It's a 128-bit address space written in hexadecimal. We use the CIDR notation, the / notation, and then a number to tell us what or how many bits are in the subnet mask. We talked about the shortcuts. We don't have to write leading zeros. We can use a : once to replace a string of zeros. We had stateful and stateless auto configuration. Stateless, the router sends us the prefix, and then the workstation, the device, configures its own host address. And then we looked at the address types: global, unicast, unique local, multicast, anycast, and EUI64. So I will do a demo, I know this one got a little long, on the auto configuration for a router. See you there.